Hello. Today I'm going to demonstrate our final project, which is called Peak 18 Smart Thermometer. So our goal to this project is that we are going to use the sensor to monitor the temperature in the room and then record the data, push it into the internet to get analyzed later. And at the end, we also made the website to pull the data from the ThinkSpeak website to show it in a more presentative way. So first, let me explain the sensor part of the project. So the first thing so in this case, we use LM35, which is the temperature sensor that will convert the temperature into the voltage signal. Then we use our PIC to read the sensor using the analog to digital converter, reading it, and then do some calculation and translate it into Celsius temperature. Now we're using this ESP8266 to push the data into the internet. So this thing works in a way that from the PIC side, we use the UART communication and then send the command AT into this ESP8266 module, and it will work corresponding to our command. In this case, you can see that we send the data into the module, and then the module send the response back. While doing that, we actually use our serial to USB converter to monitor what the ESP8266 respond to the PIC. So in this case, here you can see that it's running in every 3 seconds. So this part, so first it will start checking that the ESP working correctly or not, then starting to make the connection to the AIP ThinkSpeak.com with the port 80, and then they will start sending the data here. As you can see, 26.35 into the ThinkSpeak website, and then it will check the response if it's working correctly or not, and then close the connection. Then it keep on doing every 3 seconds. So we also show the temperature here as well on the LCD side. And to check our response, you can see that in this ThinkSpeak website, the data is get pushed in real time and it's displayed correctly. So later on, we will also pull the data to our own website. That one of the members from our team will be the one who explained it in the later part of the video. And another feature that we also add on here is that when the temperature is higher than some certain threshold, we also turn on the fan automatically. We connecting this using the relay that getting the signal from the PIC board. So now let me demonstrate how it works here, like if it's working properly or not. So here I'm going to use the hair dryer to increase the temperature directly to the sensor. So when the temperature is higher than 30 Celsius, then the fan should turn on, and also the LED here that indicating that the fan is turning on will also lit up. So it will be a little bit loud, so okay, so if you can lower the volume here. So let's do it. So right now the temperature is 26 Celsius. Then okay. So now you can see that the temperature is 33 and the LCD lit on and our fan is turned on. So our project is working correctly. Now our member will explain the part on the website that we have built. Oh, so you can see here now that, yeah, the new data is pushed up, so it's above 30 degrees Celsius. So that's it. Thank you very much.
My name is Jody Runner. For this final project, I built a website that would read in data from ThinkSpeak, and ThinkSpeak would initially get that data from, let me bring it onto the screen, this script right here. So this script would start, it would initialize the LCD, the temperature sensor, and the Wi-Fi module. And from there, the code would pretty basically enter into a while loop, and the while loop would basically just get the temperature and then upload that data to ThinkSpeak. And additionally, it would test to see if the temperature was greater than 30 degrees. If it was, it would turn on the fan, and if not, it would turn it off. And it would perform this check every 3 seconds and upload it to the website. And the website is right here. This website just basically fetches the data from ThinkSpeak using, what part of the code is it? It's a part in this right. I believe I should actually just bring up the. Let me bring this up. You would get the data using an iframe that would. You just pass in a URL right here. The URL will give what you want the graph to be displayed like in a string, and the source on their website. And from there, I just got this graph. This graph will say, hey, this is the temperature, and it will update every 3 seconds. Then it'll keep going, it'll keep going, it'll keep going. If there's a temperature spike, it goes up. If there's temperature decreases, it'll go down. Usually stay pretty constant. Temperature reaches above 30 degrees, the fan will turn on as said. And what else I could talk about in this script? This is just setting up the port for the temperature sensor. This is reading from that sensor. What else we got right here? This initializes the Wi-Fi module, and where's this stuff? I think this this uploads it to the website at ThinkSpeak, the API that we passed in. Where did we pass that in, by the way? Oh, right here, the key right here. And field, just one field's temperature. It just displays the temperature on the LCD. Then we have, this clears it. LCD port. This just sends a command to that LCD display. Since data, LCD string, blah. What else is this here? Temperature pole. So this gets the, I believe this is, yeah, this just takes the temperature and generates a float of what that temperature is in the appropriate measurement. And that's the end of file right there. All these methods pretty much called within this infinite while loop thing here. Or at least like whatever if you want to get the result, you call in temperature pole. If you upload the data, we have the thing that take care of that. And I believe that's it for this script. I believe I mentioned everything on that. Where else are we at? We have this graph here. There's the temperature going on here. And that is the project. That is our final project for embedded systems. I hope you like it. And that's it.